So the last type of bond we're going to talk about is the ionic bond. An ionic bond is an attraction between a positive and a negative ion. Remember, we talked about earlier that ions are charged atoms or molecules. So the definition of an ionic bond is, sorry, let me get my pen going here, is really here. The anion and cation, that's a positively charged, so I think T for positive, and anion, N for negative. The anion and cation are attracted to each other, and that forms an ionic bond. Now, when you're talking about ions, the implication is that at some point this happened. And this might have been millions of years ago. Okay, so this doesn't have to happen in order for an ionic bond to occur. But at some point in time, again, like I said, maybe millions of years ago, I had ions created. So this is really ion creation in this first step. And the way that ions are created is when an atom steals electrons from another atom. So an example we can look at is chlorine. Chlorine has 7 electrons in its valence shell, so it's 1 electron away from being full. It also is a very strong atom. Remember, that's referring to its electronegativity. Sodium, and I'm just going to draw 2 of sodium's shells. It has 8 in this shell. Okay, it has more shells in this. I'm just only drawing 2 of them. It has 8 in that shell, and then in its outermost shell, it has just 1 electron. So in its outermost shell, it has 1 electron. So in order to fill that shell, it would have to somehow get 7 electrons to get to a total of 8. But the easier way for sodium to get to a full valence shell is simply to lose this whole shell. It can lose that whole shell by losing an electron. If it loses that electron, then this becomes the outer shell, and that would be a full valence shell. So it will lose this electron. This electron will go to chlorine. Chlorine gains that electron and becomes full. So now chlorine has an extra electron, and remember we said that when atoms have extra electrons, they have a negative charge, so this would be a negative charge. Sodium is now missing an electron, so it messes up its electron-proton balance, so now it has a positive charge. So by losing and gaining electrons, we create anions and cations. And I just want to remind you that, again, these are 2 separate events, ion creation and ionic bonds. And ion creation can have happened a very, very long time ago, like I was saying. And so if you think about the ocean, ion creation in the ocean happened eons ago. Now there's just sodium ions and chloride ions floating around in that water. So that's what you have floating around in the water. And when we dry that water, the sodium ion and the chloride ion, they get close together, and that's the bond between them. So basically it's just them being sort of stuck together. And ionic bonds will typically form crystals. And so you're familiar with a crystal of table salt. This is a crystal of table salt magnified. Let's see here. And so this is showing you the figure from your textbook. So here's chlorine's shells, here's sodium's shells, and like I was drawing earlier, there's 7 electrons in chlorine's outermost shell. There's only 1 electron in sodium's outermost shell. So this electron will get stolen, and chloride will take it. And then chloride will now have 8 electrons in its valence shell, but a negative charge because it has an extra electron. And now sodium has lost that shell entirely, so it now has this full valence shell. And because it's missing an electron, it has a positive charge. If these 2 atoms are near each other, then they will start to line up next to each other. So you'll have a sodium line up next to a chloride, line up next to a sodium, line up next to a chloride, and then so opposite charges lining up next to each other so that they can make these ionic bonds. And because they line up in that ordered way, it's going to create a crystal. Now, when these are in water, it won't make a crystal. So when you add salt, as you probably know, to water, you lose the crystal structure. The crystal structure will go away, and that's because the ionic bonds break. So when you add crystals of salt to water, the ionic bonds actually break, and then you get free-floating sodium ions. So I'm now drawing the dissolved salt, and they're floating around in water. And so that's ionic bonds, and we'll talk more about dissolving here later in this chapter.